Hello students, today we are going to discuss about load bearing structure and framed structure. Let's see what is a load and what is bearing. Load includes the dead load, which may be the weight of the structure itself, that is the weight of the roofs, the weight of the walls, etc. Live load. Live load means the weight which changes from place to place or which moves, such as the weight of people, weight of furniture, etc. Impact load. Impact load means any load applied due to a sudden impact. Wind load due to the wind and earthquake load due to seismic waves. Bearing means the carrying capacity or the capacity to withstand the load. Load bearing structure is probably the oldest and the commonest type of structure. It is a structure in which the loads of the roof, lateral loads due to earthquakes, winds, etc. are borne by the walls, and through walls they are transferred to the lower floor and eventually to the foundation. Due to large stresses within the brick or stone walls, height of the load bearing structure is limited. Framed structure. Frame structure consists of beams, columns and slabs. In these structures, the load is transferred from the slab to the beam, then to the column, and at last from column to the foundation. Now, let's see some of the differences between load bearing and frame structure. In load bearing structure, almost all the walls are load bearing walls. But in frame structure, none of the walls are load bearing walls. They serve the same purpose as partition or screen. In load bearing structure, almost all the walls should be provided with foundation. But in case of frame structure, none of the walls are provided with any type of foundation. Walls do not go below the plinth beam. Load bearing walls are taken deep into the subsoil foundation. But in case of frame structure, only columns are taken deep into the subsoil and provided with foundation footing. Any load bearing wall should have minimum thickness of 200 mm. But in case of frame structure, exterior walls subjected to weathering elements are generally 200 mm thick. All other walls can be 100 mm thick or even thinner. In load bearing structure, walls are usually constructed of bricks or stone. But in frame structure, columns, beams and slab are all of reinforced cement concrete or RCC. In a multi-storied building of a load-bearing structure, for every wall in the floor above, there must be a corresponding wall in continuation in the floor below to support it. In case of a frame structure, there is no such necessity as none of the walls are load-bearing. Every floor may have wall independent of the one below it. Load-bearing walls are thicker. In frame structure, the walls are thinner. In the case of a load-bearing structure, the construction does not favor too many openings for windows, doors, etc. in the ground floor as required in the case of showroom, etc. as the load-bearing length of wall is considerably reduced. But in the case of a frame structure, the space between the column can remain as open space as the case with multi-story residential flats where the ground floor is left with no walls for easy parking of vehicles. In the case of a multi-storied building of a load-bearing structure, the carpet area is reduced as we go down due to thicker walls. In the case of a frame structure, the thickness of wall remains uniform. Therefore, the carpet area in any floor remains the same. The load-bearing structure may not withstand seismic forces and other type of vibrations since bricks are bonded together. But in the case of frame structure, more rigid and withstand seismic forces because of the entire frame of column, beam and slabs act as one unit of RCC. In case of load bearing structure, the plan of different floors must be the same. But in the case of a frame structure, the plan of different floors are independent of each other. In load bearing structure, the beam and columns are not there. Hence, wall have to be first built. In case of a frame structure, walls are constructed after the frame is ready. So that's all about load bearing structures and frame structures. Thank you.